In this example code called IR motor, my goal is trying to close a loop for the sense, think, act paradigm. So we're sensing through the front IR, thinking it done through a CM510, and the actuator going to be is actuator number 4, which is right here. So that's just a simple to create the loop, sense, think, act. So this code is already created. I'm just going to go over and explain how the code works for you. So when the program starts, we have call initialize, and call initialize is a function down here. So what it is, have an if statement, basically checking to see your address 8 for ID number 4, that means servo number 4, which is the counterclockwise limit for the servo. You would not set to 0 and then set it to 0. So essentially, this is the custom programming to access the servo number 4 at address 8, which is the one of the ROM procedure that are already built in for it directly. And how do you access that? You double click on it. It's under custom. And then for ID, you put in the ID of the servo, which is 4 in this case, and address 8, and that you have to come from the website for Robotus, where they list all the address and what all they mean. Also on that website, it will list whether you need to use a byte or a word. In this case, it's the word, so 16-bit number. So click OK. So that's how you get it set up. So essentially, if it's not set to 0, and then set that address 8 to 0. This essentially, physically, it set the AX12 to a wheel mode. Okay, so when it's done that, finish up call initialize, you get into an endless loop. And what does it do first? It pick up, go to port 1, read what the R reading is, save the variable called front IR, and then we'll print with line the front IR value we read. And then this is a key. If you remember in the text, this is the first time we use, or officially we use the reactive control approach. So reactive control approach, first step is always set up, figure out a set of mutually exclusive conditions. So the condition pretty much depend on what the reading of the front IR is. So I essentially have several mutually exclusive conditions if the front IR f less than 40. So if that statement is true, it will go do something called move 1, and we'll go into what is move 1 a little bit shortly. If this is false, that means it's bigger or equal than 40. You're going to trigger this else if. And because it's already bigger or equal to 40, I want to check it's only with less or equal than 80. So that means what? My first condition is when the front IR less than 40. My second condition is essentially when it's bigger or equal than 40, but less or equal than 80. So between 40 and 80, I want to call buzzer 2, and I want to stop. Okay. So it could be another third condition is when it's bigger than 80. I'm going to trigger the else if. And the question is, do really I have to write an else if here, or should I just use else? Okay, but let's leave for a moment. As we say an else if front IR bigger than 80, call something called move 2. And then I find the else, that means what? When none of the 3 conditions apply, it triggers this else. If anything else will apply, we want to call buzzer 1, we call it stop also. When we run the code, we'll see if this condition actually ever triggered for our particular case. So let's go back. What is move 1? So when front IR is less than 40, it's supposed to call move 1. And call move 1 is down here. Okay, and what it does, move 1 is whatever the front IR reading is, multiply by 20, assign to parameter speed, and then assign it and make the servo number 4 here, move it counterclockwise with that kind of speed. So if you remember, the IR reading is the closer an object is close to the IR sensor, the bigger that front IR reading is. So that means as I approach the sensor, if it goes here, its speed will increase as I approach my hand from very far away. It starts increasing the speed of number 4 counterclockwise. Okay, eventually go here, so that will be triggering when it's less than 40. So between, say we say 0, a small number, with strictly less than 40, it's going to turn counterclockwise with increasing speed as I approach my hand. Eventually, it's going to be bigger than 40, but less or equal to 80, and then call buzzer 2, and then it stops. So what is buzzer 2? Buzzer 2 essentially memory 0, and call stop is set to velocity 0, so it stops. So it should be is I move my hand from far away to closer. First is trigger move 1. And then when it's between 40 and 80, it should give a buzzer 2. It stops the servo motor. And as I approach further and further, eventually it's going to trigger bigger than 80. We're going to trigger call move 2. So what is move 2? So move 2 is whatever the R reading is, multiplied by 5. But then speed is reset by 1023 minus the speed. So when it's in the zone where it's bigger than 80, servo number 4 actually go counterclockwise, and as I approach my hand, it actually slow down as I get closer and closer. Okay, so it's just the reverse of the fire zone, essentially. Okay, and buzzer 2 is now 0. Remember, buzzer 1 is the else here, and then it also stops. So we'll see if it ever stops. So if I approach closer, and when none of the 3 conditions here apply, simply call buzzer 1 and stop. Buzzer 1 melody 10, buzzer 2 melody 0. All right, let's try and see. So shouldn't have any error. Total no error. Okay. And then we have COM3. Use on. Download the program. You're out for the program. So let's push the start button. Okay, so see it's reading about 11 now. And you can see that the servo number 4 turning clock 5. I have my hand here, I'm approaching it. You read 12. So it's increasing, still going clockwise, 30. I'm okay, I'm at the limit. So I'm at the limit, 45, 46. It stopped the servo motor and it gives that music sound. I'll approach it. 60, 65, 70. Here we go. I got 80. And then it go the other way. So the other way is the more I get closer, the more it's slowing down. Eventually, it practically stops. So I'm the 0 zone. So I'm slowing out. Go kind of clockwise. I'm going in. In the dead zone, essentially. And I pass beyond it. We go the other way. As it get closer, it's slowing down, slowing down, slowing down.